Hello, this is Jia, and we are going to do divisibility rules. As I just prepared this for school, it is chapter 6. So please ignore this. It is related to the chapter of factors and multiples, in which HCF, LCM, and all comes. So we need to know if it's divisible to make it fast, to make the process fast. So it's exactly divisibility rules, and it's by me, Gia. Okay, let's continue. Divisibility rule of 2. So the divisibility rule of 2 is that the number should be even. So even digits are the digits that can be divided by 2 completely on. So the last digit, if it's a really large number and you're not able to identify if it is an even number, so you should just see on its one's place, that is the last digit, please remember this. It should be 0, 2, 4, 6, or 8. For example, I have 34 over here only, so the last digit is 4. The last digit, we count from the right hand side. This is in tens place and this is in the ones place, so we exactly have to see in the ones place, and it is 4, so fourth, so that to make it even over here, yeah, we have 4, so it is even and it is divisible by 2 because it is even. So now we have a question: is 94 divisible by 2? Hmm? So over here, 94, 94, the last digit is again 4. So in the ones place we have 4, and 4 is what makes it even. Correct. It's what makes it even. And so it is divisible by 2. So it's a yes. And how even? It is even. I just made it some kind of. Okay, I'm not really good at computer writing, so let's just go on. So the divisibility rule of 3. The rule of 3 is that if you add all the digits of the number and the sum is divisible by 3, then the whole number is divisible. Now this is a little tricky, so that's why I took a number example. For example, 222. So we will add the digits. No, we're not going to add it around the numbers. So we have 3 digits, which is 222 is basically made out of 2, 2, 2, just as different place numbers. So it's 200 plus 220 plus 2 is its expanded form, right? But we're just going to add its digits, which is 2, 2, 2. So 2 plus 2 plus 2 is equals to 6. So, and 6 is divisible by 3 how many times? 2 times. Now, so did you understand this, guys? If you please do not understand any doubts, please put it in the comment section. Yes, and please subscribe to my channel, Rachna Rajput. Rachna Rajput. Subscribe. Now, this is not the end of the subscribe. Yes. Now the question is 56 divisible by 3? So unlike 2, we do not look at the ones digit. We add the digits. So what 56 makes, it is by 5 and 6. So we will add 5. Maybe I should just change the color to white. Yes. 5 plus 6, which is 11. So I'm just giving it how, the reason, okay? So I better not write. And 11 is not completely divisible by 3. How? Because over here, let's just take this. Okay, and 12. It's too big because it's one big, so you'll 3, which is 9. And after we subtract 9, we get 2. And 2 is small than 3, then we have to put a reminder. That's so 11 is not divisible by 3, so it's a no. Let's go forward. Please tell if you understood it. So the divisibility rule of 4. Now this is a very easy. So if the last two forming digits are divisible by 4, then the whole number is divisible. So for example, on the last two digits are 4 and 8, they make 48. We are not going to add the digits. This is not correct. No. So 4 and 8. Don't put a comma. What do you see? 48. So is 48 divisible by 4? Yes. How many times? 12 times. So now the question is 80,857 divisible by 4? Ooh. So what do we do? The first step is the last two digits, 5 and 7. What do we get? 57. Right. So if we use 57, what is this? 57. Sorry, I just hang out. So is 57 divisible by 4? Let's check, okay? I've took 5 and 7 and 4. Okay? So I'll do one time. 1 went down, and I'm just going to put 7 right here. So 4 fours is 16 minus 16. As you might know, it's 1, and 1 is a reminder. So the quotient is 14. But the reminder, we have a reminder, and the reminder is 1. So it is not divisible by 4 completely. So it's a no. And how? It's I just told you. So whenever I say how is what I'm explaining to you. Yes. Now the divisibility rule of 5 is a very very easy rule of divisibility. If the last digit of the number is 0 or 5, then it is divisible by 5. Let's recall the table of 5. 5, 10, 15, 20. Let's just stop here. Okay? When we write down the table of 5, what do we notice? That the ones digit is always 0 or a 5. Or let's just take 15 fives. 15 into 5. What do we get? 75. And what about 14 into 5? What do we get? 70. So every multiple of 5 is a 0 or a 5 at the end. So, for example, if you still did not understand, I just took another example. This is last digit is 0. So 0 is the last digit in the number, so the whole number is divisible by 5. So if the question is 82,950 divisible by 5? I think it's a yes. Why do we think so? Please put your answer in the comment section below. And just don't make any kind of mistake. Don't touch the web. It's don't memorize. Yes, so the divisibility rule of 6. And this also has easy, but if you want, you can also give the answer below in the comment section much clearly. Yes, if the number is divisible by 2 and 3, then the whole number is divisible by 6. So, first we have to put two tests, okay? So for example, I have 1,122. So the last digit should be even, okay? It's an even number because it has 2 in the last digit. So it is divisible by 2. Okay, by 2. Since they both get tick, means it's a tick for 6 too. So for 2, yes. Now for 3, let's see the sum of the digits. So 1 plus 1 plus 2 plus 2 equals 6. So 6 is divisible by 3 again, so it's a tick. So 1,122 is divisible by 6 because it has a tick for 2, 3, so it should give a tick for 6. We cannot leave it alone. Now, the question is 330 divisible by 6? Well, it looks 111 times divisible by 3 because it's just a 1, 1, 1. One time and another one time and another one time. The question is this, but the question is it divisible by 2? No, nope, because the last digit is 3 and 3 is not an even number. So it's a cross for 2, then it's a cross for 6 too, because it has exceptions. If my friends 2 and 3 are going together, then I am going too. If only 3 is going, I won't be going because 2 is going to stay back. So it is not divisible. Let's go. Now, the divisibility rule of 7, I skipped it because it's quite tricky and won't come in handy most of the time. For class 5, usually, I have given the divisibility rule of 8, which is a easy divisibility rule, but this is usually applied for very, very large numbers, especially the numbers who are going in thousands or in hundreds. It might just go on. But if the number is two-digit number, then it won't really apply. Whatever, let's start. If the last three digits are divisible by 8, then the whole number is divisible. So what you have to do is, over here I have given an example. 49,952. So the last three digits are 952. So we'll take it as 952. And it is divisible by 8 119 times. So we don't have to divide this whole number and waste our time. We just have to divide this last three digits. And if they are divisible, then the whole number is divisible. Even if it looks like it doesn't come in the table of 8. Okay, let's move on to our question. Is 10,848 divisible by 8? Yes or no, and how? Now, we'll take the last three digits, 8 or 8. So what do we make? 848. Yes, now, is it divisible by 8? Let's check, okay? Yes. So, if we want to divide by 8, so we can take 1 times, because minus 8 down 0. Now when I do 4, it's not actually very small, so to bring the number down, we have to put a 0. Means it went 0 times. And when we put 8 over here, minus 48. Oops, I forgot to mention how many times. Okay. So 8 5 is a 48, 6 are 48, so we have to put a Z. So yes, so 848 is divisible by 8. So it is divisible. So and 10,848 must be divisible by 8. So it's a yes. The divisibility rule of time. It has the same rule as three's rule of divisibility. So we have to find out the sum of all the digits. Example 93,213. So we have to add 9 plus 3 plus 2 plus 1 plus 3. And when we add, we get 18. And 18 is divisible by 9. So 93,213 is divisible by 9. Yes? So this question, which is name one four-digit number that is divisible by 9, but it should have different numbers. By different numbers, I mean it should have different digits. For example, if you give it a number like this, I'm not really making it divisible. I don't want this 7 to repeat, means no repeating digits. I want all the digits that are different. Okay, so there are many examples of these numbers, so please put it in the comment section. Okay. Ooh, that was nice. Okay. Okay, so divisibility rule of 10. If a number has 0 in the last digit, then it is divisible by 10. For example, I forgot to put commas. Oh, yes. 1,90,480. It has the last digit, means in the ones place it is 0, so it is divisible by 10. Question again, name one number which is not divisible by 10, but it should have 10. Okay, so let me give you a tip. If a number has 0 in the last digit, not in any of the between digits, so if it is in the last, only then the rule will work. If it's in the between or somebody else, then it is not divisible. So please keep that in mind and give me the answer in the question. Over here, I have a YouTube link over here. I just got this song. You can actually had there are many songs, and I had just one more slide to show the divisibility rule of 11. So after that, we can watch it. The divisibility rule of 11. If the difference of the sum of the digits at odd places and the sum of the digits that are even places is either 0 or are divisible by 11, start from the right. Tips, start from the right. So, did not understand, right? So, example, I have taken 2,794. So the sum of the odd places. So from the right, we start from the right. So this is 1, this is 2, so 2 is an even. 3, so this is at the third place and this is at the first place. And this is for the fourth, so it's even. So the even I have put it up on the mark, and for the odd I have put down. So 7 plus 4 is equal to 11. If the sum of the digits at the even places, which are 2 and 9, so 9 plus 2 is equals to 11 also. So now we have to find out the difference. So 11 minus 11 is 0. So 2,749 is divisible by 11. Now if the difference would have come like 22 or 33, and 22 comes in the table of 11, so it is divisible by 11. Okay, so if the difference comes always 0, it's not important that the difference should come 0 only. It's just that if it comes as 0, then it is divisible by 11. And if it does not come 0 and comes like 22 or 33 and is divisible by 11, then it's the whole number is divisible. So over here, I'm don't. If you want, you can give it in the comment section, but I think I should solve it in this. Over here, this is the first, second, so it's an even up, third, odd, fourth up. So 9 plus 2, we have to add 9 plus 2 is equal to 11. And 7 plus 4 is also equal to 11. So we have to subtract 11 with 11. Ooh, I did not notice. That's a coincidence. We have the same thing. It's equal to 0. So it is divisible. Oh, I did not put yes or no. Well, it is divisible. So I just put a tick. Yes. And let's go to the previous slide. I'm gonna just put this in. Thank you for everything. You have been such a lovely audience. So actually, this link only works when you are presenting your whole screen, which I'm not very sure how to do it. So you can also give me a tip, or you can just find some fun videos on divisibility rules. Thank you very much. And this is Gia closing. Thank you again.